Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buetow, Editor-in-Chief of PCD&F and Circuits Assembly. Today's podcast is sponsored by PCB West, the leading conference and exhibition for the printed circuit design and manufacturing industry. Join thousands of engineers and designers this September at the Santa Clara, California Convention Center. Visit the website at pcbwest.com for information. My guest today is Jim Barry. Jim is Sales and Marketing Manager and Technical Liaison at PCB Technologies, a fabricator of rigid flex, and flex PCBs for high-rel applications. Jim has been in the PCB industry since the 1970s and has several years' experience at Parlex and Eltek, the flex fabricators. He's also worked for various EMS companies before joining PCB Technologies. Now, I've invited Jim on today as he is one of the presenters at the upcoming SMTA Capital Chapter Technical Day in June. This all-day workshop features 3 talks on DFM, design for reliability, and thermal and RF mitigation concerns. Jim, why don't we start by getting a rundown of what you'll be talking about next month?
Well, Mike, thank you, first off, for inviting me to this podcast, and thank you to the SMTA DC chapter for having us on the technical day. I've been around nearly 40 years in the industry with an engineering materials background as well as design and fab, so I've got some deep knowledge. The talk we're going to be doing coming up, we had originally 4 subjects. We've combined it into 3. The first subject will be RF microwave and design considerations and options, and it will be presented by Yad Alaya. Yad is our Chief Technical Officer. He's a brilliant engineer, has come up with some innovative solutions in the industry for RF and microwave, including things such as air cavity, air tunnel, etc., for some of the high-end Israeli aircraft industry. Yad will be presenting some of this new technology. We'll have samples, we'll have demonstrations, we'll show stack-ups and give you some of the pluses and pros that you get from this new air cavity technology. In addition to that, I will be speaking on thermal mitigation options at the raw card level. As we know in the industry today, packages are getting more advanced, smaller, tighter designs, trying to pound more into the design, which generates a tremendous amount of heat. And as we know, heat is a definite negative to the PC board, PCB and PCBA, as it can cause plated through hole failures. So we're going to look at the thermal mitigation at the raw card level. How do we consider design enhancements to keep the thermal out or get the thermal out? We're going to look at items such as coin technologies, heat pipes, via plane fields, materials, different things like that we've experienced and that we provide to our customers to get the temperature out at the raw card level, so you won't have to go into the big, heat sink and heat pipe external type things. And then the third subject, we've actually combined 2 subjects. We're going to talk about design for reliability, DFR, and we're going to talk about design for manufacturability. Both subjects have unique characteristics. As a manufacturer of high-density, high-rel products, we see mistakes being made all the time, whether it's for cost requirements or lack of knowledge, whatever it is. So we're going to talk about how you can design your board to make it the most manufacturable across the board for multiple suppliers as you can. The second part of that talk will be design for reliability. What things can you do in your design, in your layout, in your stack-up that may improve reliability long-term? It could be as simple as choosing the right materials that match. I mean, there are a lot of good materials out there in the industry, but not all of the materials that are out there are actually manufacturable or provide long-term reliability. As a supplier, we test a lot of these materials in-house through HATS testing, and we can say, it might meet its particular IPC specification, but if you use this material, you'll get more than 1,000 cycles. So we're going to look at DFR and DFM, in the board and with the designers. We think this is a really good opportunity. It's a full day. It allows all of the companies out there, the users, the designers, to sit down with a PCB manufacturer who's been doing it for 40 years and to pick our brains, ask us questions, ask us the do's and don'ts. So we're pretty excited about it.
Jim, let me go back to one thing. With the thermal mitigation, in your experience, do designers simply not understand all of the factors that go into managing heat at the board level? Or is it something that they say, well, that's really the responsibility of somebody else, and so they kind of leave it to another engineer?
I think there are different levels. So to answer your question, yes, a lot of designers, you've got your EEs who are designing the connections and the traces and the layout. You have your MEs who are looking, does it fit in my box? Does it do what I want? But then sometimes what gets overlooked is the component design. This component runs at this heat, and the placement of that component may not be conducive to the components near it. So one of the things that we talk about are the methodologies that a designer should think about. First materials, next copper or vias, next, internal heat sinks. Do I have to go to coins? And we look at the difference of spot cooling versus mass cooling. I mean, you can have a design and have one particular component that you have to use that component for some specific reason. Maybe it's speed, maybe it's a logic, I don't know, and that one component drives the temperature up beyond the TD or TG of the board. So you have to think about that. Some boards, when they're designed, I think I see it more in the larger companies, that the large OEMs will actually do a thermal analysis of the board and run that thermal analysis to see. But not everybody does it, especially the smaller tier 2, tier 3 guys who lay out and design a board. Thermal is not something that's typically considered, and we've also seen huge increase in the board's effective behavior or the performance of the board. We once built a board for an imaging device, which was a high-speed imager, and it had large components that were located, and by reducing the temperature of the board, we actually improved the performance of the imagery of this high-speed camera. So, we might be able to enhance the design by looking at it. So I think sometimes it's an oversight or not thought of. Other times they think about it, but they feel, well, we'll just take the temperature out of the box later on. So it should be looked at the board level.
And which different flex materials does PCB Technologies use? I'm sure you're polyimide.
Yes, we do polyimides, all types of RF materials. We do LCP, liquid crystal polymers. We do some uber thin Panasonic materials that are, used for small medical device implantable. We have various materials that we use. We look at the design, we look at the application, and we try to discuss with the OEM or ODM what's the specific goal for the build. We'll do probably a 60-40 split between rigid flex, and then rigid. About 40% is rigid. And the designs are just getting smaller and smaller and smaller. Examples are, we do 2 rigid flexes that go into an implantable device. Temperature can be a real big issue when you're dealing with implantable. The medical industry is just pushing the edge of the envelope, and the mill aerospace is following right behind. We do some very tiny night vision goggle type technology, and it's all blind via. It's very, very dense. We're talking 2 mil pitch, 50 micron lines. So when you start cramming that much into a package, heat just starts to destroy the board, destroy the components, reduce the performance, and kill the reliability.
Is there any limitation to using coin technology? Can you use that in all the different flavors of flex materials?
We can. Coin technology has been around for a while. A lot of people don't like to do it because it's a bit expensive. It's a unique process. There are people out there who press fit in coins. We don't press fit. We actually embed our coins within a board. We can do it on a rigid flex. We can do it on a rigid. We are actually going to present a very amazing board. I've written about it on my LinkedIn page and had thousands and thousands of hits. It's actually an RF board that has multiple coins that are embedded. It has dissimilar materials inside, RF and polyimides. It has blind buried. It has a buried resistor technology, and it's really unique because it has dissimilar materials on a single plane. And we'll have that board at the conference. We'll show it. We'll talk about it. People can handle it, look at it. We recently did an IMAPS presentation last week with some of our RF technology in the air cavity and the sensors, and people went wild over it. They love the idea. They want us to come in and talk to them and present. So we're getting a lot of good rapport out there in the industry of people wanting to see some of these new technologies. Thus, we thought doing this SMTA where we can kind of present, and this is not a sales pitch. This is a day of our CTO and myself, being a 40-year veteran, talking about what we've seen, what we've done, and how we can help people out there in the industry.
And you were recruited by Karen Ebner and Raytheon to make this presentation, correct?
That is correct. I had visited Karen a few times, as well as Mike at Raytheon. They both saw what we could do. We showed them some of the technologies. They understand the depth of knowledge we have and some of the problems the industry is seeing. In fact, we're speaking this week as well. My CTO, Yadalier, is flying over today to speak at the IPC High Density Conference, which is being held this week in Baltimore. We're speaking one topic there, and then he'll be back in the June timeframe to speak at the SMTA and do another presentation for the IMS microwave. We're trying to be more and more involved with the OEMs and ODMs. I mean, the U.S. PCB market or PCB supply base has dwindled somewhat, as we know, over the years. Some of the technology is being lost and going away. We're trying to do the opposite. We're trying to infuse more options, more answers, more reliability, into that middle aero defense and medical market. That's really our pitch here.
And Jim, would you say these presentations are based on theoretical concepts, or are they more about real-world experiences?
A lot of these are real world. These are not theoretical. We are building today with the coin technology. We'll show stack-ups and show boards we're actually building. The heat pipe is something brand new. I haven't seen one in my possession, but I believe that's something we're doing as well. So blind, buried, coin, mixed, RF, all of these things are available today. We're doing double cavities on rigid flex and rigid. It's going to be nice because we'll have some samples there on a table that people can touch and look. I'm sure when we start the conversations and we start doing the presentations, as is typical with a large group of engineers and designers, the conversation tends to take turns left and right and up and down, asking questions about, hey, we did this and we saw this. What do you see as a supplier? And we're there to help. We're there to give whatever knowledge we can share. There's nothing really proprietary that we're afraid to speak of. We're going to be completely open, share our processes, what we're doing, how we're doing it, and then technology in the samples. So it's going to be completely open. I think it's going to be a fun technical day of sharing knowledge around, and I think it's going to be great. I'm looking forward to it. I've done a few of these for the smaller groups at the SMTAs, and it's been a great turnout. We've had a lot of good questions, a lot of people saying, geez, I didn't know you could do that, or how about if you do this? And it's just amazing. It gets the mind flowing, it gets the ideas passing, and hopefully we can solve some problems.
Who would benefit from attending?
We're focusing this on designers. So designers would be a major group. New designers coming out of college that have no experience. Old designers that have been around for a long time and just want to see, hey, what's new? What are you doing? I didn't know you could do that kind of thing. But it can also be great for the assemblers, the contract manufacturers, the EMS providers. If there are program managers who want to learn that, maybe there's a program or there's an issue or a problem they have, folks that are in the infrared industry, definitely the folks that are in the microwave RF industry, it's a big hit. So, the Raytheons, the BAEs, the Rockwells, the Northrop Grumman, all of those folks, whether it be programs, designers, reliability engineers would I think have a big takeaway on this. The OEM and ODM box build folks. I was at the IMAPS last week, and I saw from an amazing technology for the first time. It was a small compressor to generate cooling that fit into the palm of your hand. So I'm going to bring some pictures of that. It's just amazing that the more of these kind of technology transfers and crossovers for different groups, the more we share, I think the more that people can find solutions to a lot of their problems. I've had a lot of people say, geez, I didn't know you could do coin. And, it's really opened up their eyes. I think so. One other point, I think the whole, the design for reliability and design for manufacturability, it's been done over and over and over many, many times, but we're going to try to, look at things like, non-functional pads, adding them, taking them away, via fill, stacked versus staggered, things like cross-hatch grounds in the rigid flex, conductor, routing, preparation, pad sizes, pad spacing, blind, all of these things that designers face. I did a design conference a few months back, and I had about 30 folks, all design engineers from a company that won't go unnamed. But the first question that I asked all of these designers who were designing boards were, how many of you have ever visited a PCB shop, a manufacturing line? And not a single hand went up. And I was surprised and shocked that we have many, many young designers out there who are designing boards based on theoretical knowledge from books, classes. None of them have actually gone to a PCB supplier, watched the process, understand the process, or understand what their decisions actually could change, whether it be cost, reliability, and a board. I mean, the simple fact of putting in a staggered via versus a stacked via could tremendously reduce the price and improve yield. So, the design for reliability and manufacturability, I think that's a huge amount of info. So I'm hoping we'll see a lot of young designers and folks who haven't been to a PCB shop so we can explain the process and, talk about how we build something and why it's important when you lay it out. A simple decision can increase the cost 3x just by one simple decision.
Well, that's a great point. That's been an issue going back to when I entered the industry back in 91 and started working with designers, and many of them back then hadn't visited board shops, and I think today it's even more pronounced.
Correct.
Just because there's fewer board shops than ever, especially on the East Coast. So this is a great opportunity for those folks to get a firsthand look, I think, at what the technologies are, and then perhaps maybe follow up with an actual visit. I mean, I know PCB Technologies is based in Israel, but there's certainly other opportunities as well.
Every time that I meet with people and sit down with people, I have one customer that I go visit every other week, and I look at all their designs and I help them out. I hold their hands, and we do stack ups for them. And we'd like to get work from them in orders, but it's all about sharing and trying to help people, not make mistakes with their designs. And it's all about knowledge and learning and teaching. And, I've been accepted well throughout the industry as someone who's got a 40-year background. I've sat on both sides of the fence as the user, as the manufacturer, as the designer. I have a failure analysis background. We're hoping just to share all that.
Great. Well, Jim, I want to thank you for coming on. And I'll remind listeners that they can see Jim in action at the SMTA Capital Chapter Workshop on June 11th.
Thank you, Mike.
For more information, visit smta.org and look for the DC chapter events on the event calendar. And I want to thank our sponsor, PCB West, the leading conference and exhibition for the printed circuit design and manufacturing industry. Visit the website at pcbwest.com for more information. For PCB Chat, I'm Mike Buetow. Have a nice day.